So we're going to be graphing the graphs of sine and cosine. We'll start with a basic unit circle, and we're going to focus just on our quadrantal angles. So I'm going to make a table of values for x and y equals sine of x. So we'll start off at 0, where the sine is 0, and then at pi over 2, where the sine is 1, and at pi, where the sine is 0 again, at 3 pi over 2, where the sine is negative 1, and then back to 2 pi, where the sine is 0. And now I can take those values and put them on a graph. So on my x-axis will be my angles. Let me just draw pi over 2, pi, 3 pi over 2, 2 pi. And I'll make this one and this negative 1. So I can plot my points. 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, 2 pi 0. And then that will give me one graph, or one cycle of the graph of y is equal to sine x. But I can also think and go in the opposite direction. So for the angles, these negative angles, I'm going to be moving in the opposite direction. And so I'll start, I have 0, 0 here, but then I'll have negative pi over 2, where sine is negative 1, and negative pi, where sine is 0, and negative 3 pi over 2 is going to be all the way up here, negative 3 pi over 2. Where sine will be equal to 1. And then back to negative 2 pi. It's going to be 0 again. And so that would be 2 cycles of the graph of sine. Now, typically our sine function can be written as y is equal to a sine bx minus c, and then it's plus or minus d. We'll just write plus d. So what these represent are going to be, a will be a change in our amplitude. B is going to be a change in period. So the period change will be 2 pi divided by b. The bx minus c is the phase shift, what we call a phase shift. And d is a vertical shift. So I like to look at these changes in terms of, do they change my x value? Do they change the angle? Or do they change my y value, the ratio? So it turns out A and D are a change to the y value. Those are the easy ones. And bx minus c are the change to the x value. So they're going to change the angle that we graph. So let's look at a little example of that. Let's say I want to graph y is equal to 2 sine 2x. And so typically what I like to do is I take this 2x and I set it between let me write it like this. I take the whole bx minus c and set it between 0 and 2 pi, because 0 and 2 pi is where the original graph starts. And then I solve for x. And that will give me where my graph where one cycle starts and where one cycle ends. So in this case, we have no shift. We're just going to put 2x between 0 and 2 pi. And I'll divide all three sides here by 2. That means my graph is going to start at 0 and it will end at pi. And now this is my new period. Now I'm graphing 5 points. That means I have 4 spaces between those points. So my increment is going to be to take the new period divided by 4 gives you the increment between points. So we'll make a table of value. The other change that's happening here is that I have an amplitude of 2. That means I'm going to multiply my y values by 2. So for the x's, we're going to start at 0. We're going to add pi over 4. So pi over 4, then pi over 2, then 3 pi over 4, and then we would end at pi. And we're taking our basic 0, 1, 0, negative 1, 0, and we're going to multiply those numbers by 2. That's exactly what's happening here. So that gives us 0, 2, 0, negative 2, 0. And let's just do 1. We'll do 1 cycle of this new graph. So 0, 0, pi over 4, 2, pi over 2, 0, 3 pi over 2, 4, negative 2, pi, 0. Now if I wanted to compare that, if I wanted to compare that to the regular sine graph, let me just do y is equal to sine x in red would look something like this.